Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank ExcelR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about ExcelR and I enrolled in ExcelR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing.
Good evening, all. I hope you all doing well. I hope I am audible to everyone. Students, kindly confirm, is my voice audible? Okay, okay. Yeah, thank you for the confirmation. So, good evening, Murli sir.
Yeah, very good evening.
You can start the session, sir.
Yeah. So is my voice audible to everyone?
Yes, sir,
Can you
you're audible.
confirm in the chat? Okay. So let's start today's session. So today's session is all about AWS Load Balancer. So let me start with the introduction of Load Balancer. So what is Load Balancer? So let me share my screen first. So load balancer is distributing incoming network traffic across multiple targets like EC2 instances, containers, IPs for improving application availability, scalability, and performance on automatic failover. So let me draw you. So these are the incoming traffic from the user. So this is the load balancer from Amazon. So which is in between the server and the users. So which will distribute the incoming traffic. So you're looking on the screen. So there will be millions of users. So they will be accessing these instances in their application. So when the traffic aids, the server gets load. So to distribute this load, there is a load balancer. So, for example, in a real world scenario, so just imagine there is a traffic cop as a load balancer at the highway toll phase. So, if there are hundreds of incoming vehicles at the single line, so there will be a lot of traffic jam. So, that's the concept behind this. So, the cop acts as a load balancer. He will distribute the incoming traffic to n number of lanes. So there will be a smooth flow of vehicles. So when we consider it as in a software industry, so let's take an e-commerce application. So if one EC2 instance goes down during peak hours, so without load balancing, so all users experiences the downtime. So with load balancing, it automatically routes users to healthy EC2 instance in multiple availability zones. So that's the concept we are started today. So let me discuss the types of load balancer. So there are mainly three types of load balancer. First one is application load balancer. The second one is network load balancer. And the third one is classic load balancer. So let me write it. So what does the application load balancer does? So it handles HTTP request or HTTPS request. So it has a advanced routing capability like path-based and host-based. For example, so consider a web application or a microservices. So you have a domain like, for example, www.myapp.com. So it has users like /users /admin /static. So my application will be running in www.myapp.com. So there will be a server running Node.js service. It is running on port 3000. And another EC2 service is running on port 8000. And the static file web application is running on S3. So it is a path based. So whenever the users log in, it shows it will distribute the traffic to the Node.js service where the EC2 is running. And if the admin users log in, it running on the port 8000. If only users starting using a static website, it will run on S3. So it distributes the traffic based on the path paged. So this is one kind. The next one is network load balancer. So it handles at layer 7 of the transport layer. So usually like TCP protocol, UDP protocol, or TLS protocol, it has a low latency and high throughput. So for example, uh, we have a gaming application or financial application like trading. So when you're building a trading application which requires low latency, so these network load balancer act as a low latency platform which serves millions of requests per second. So that's the concept of network load balancer, TCP protocol. UDP protocol and TLS protocol. So whenever there is a request from TCP, UDP or TLS protocol, so these requests are distributed by the network load balancers to the servers. Servers in the sense EC2 instance. The next load balancer is a classic load balancer. So classic load balancer, it's a legacy. Means previous generation load balancer. So it handles both app- application load balancer and network load balancer, but it is less intelligent than the network load balancer and the application load balancer. So that's the reason the classic load balancer are minimally used. So let me start implementing in the AWS cloud. So how to set up the application load balancer. So first we will create two EC2 instances. On that we will set up the load balancer and we will check how the traffic is distributed to one server or the second server. So that implementation I will go on now. So let's launch EC2 instance first. So let me name it as a test app server 1 and select the OS image as Ubuntu. So instance type, let it be t2.micro. So selecting my key pair. So if there is no key pair, you have to create a new key pair. So VPC, I'm selecting the default VPC, and subnet also default subnet it will going to assign. And the security group. So I'm selecting HTTP protocol. Port number 80, I am allowing port number 80 and port number 22 also. And then launching the instance. So let me launch another instance. Selecting the Ubuntu image, instance type t2.micro, key pair, selecting my key pair key North Virginia. So selecting my security group launch wizard 1, which has port number 80 and port number 22 as the inbound rule. Port number 80 for HTTP protocol and port number 22 for SSH to log into the instance, EC2 instance, and then launching the EC2 instance. So we have two EC2 instance running. So let me configure for the web server. So first I will log into the Mobex term. So this is the public IP of EC2 instance 1. So username is Ubuntu. Selecting my key pair North Virginia PEM file. So first I will update sudo apt update. So next I'm going to install Apache web server. Sudo apt install apache 2-y is a command to install Apache web server. So let me check the Apache application is running or what. Sudo systemctl status Apache 2. So the web application is running on the EC2 instance. So let me go into the index.html and name it as this is a server 1, so that we will be easy to identify the server when we hit the DNS name in the browser. So let me show you the IP on which the Apache is running before this override. See, the web application of Apache is running on EC2 instance 1. Let me override this. So I'm giving the name, this is the web server 1 for easy identification. So can you see this is a web server 1. So if I go to that browser and refresh, so you can see this is a web server 1 for easy identification. So let's do the same thing on EC2 instance 2. So selecting the key pair. Yes, logged into second server. First updating the packages. Then installing the Apache web server. Then checking the Apache 2 web server is up and running or what. Yeah, it's up and running. So let me rewrite the index.html file. So I'm naming it as this is the web server 2. So which is located in var.www.html/index.html file. So you can also check in the browser. You can see this is web server 2, this is a web server 1. So let me start creating the target group first. So create a target group. So selecting the target type as instance. So naming it as test target group. So it is a default VPC which I am doing. So I'm keeping everything as default, L checks. So next. So selecting both the instance and selecting include as pending below. And here creating a target group. So next, let me create the load balancer. Create load balancer. We have three types: application, network, gateway load balancer. So this serves HTTP and HTTPS request, and network load balancer serves TCP, UDP, TLS request from the users, and the gateway load balancer is running the third-party applications. So let me create the application load balancer. So naming it as test application load balancer. So selecting schema as internet facing. So it should serve internet traffic. So it will be having a public IP address. So it will go DNS name resolves to public IP. So selecting VPC in the default subnet. So checking box US East 1A, 1B, and 1C. In these, the EC2 instance is running. You can select any two. So selecting security group, launch wizard 1, which has port number 80 and 22. So in the listener and routing, so we are selecting what we have created the target group, in which the EC2 instance are registered. Two EC2 instances are registered here. then creating a load balancer. So still it is in a provisioning state. Wait for some time, it will be in active state. So let me check the target group, whether it is registered properly or not. Yes, both the servers are registered. You can see the load balancer is active. So let me test the application. So we have a DNS name. If you open the browser and paste so the first request goes to the web server 2 and the next request goes to the web server 1. So you can see the difference. This is web server 2, this is web server 1. So if we go back to in one of the instance and delete these test apps ECD instance to test app server 2, you can see the difference. The application load balancer will distribute only to the test app server 1. So once it is terminated, you can see the difference in the browser. Now you can see the test app server 2 is successfully terminated. You can see, so it will only distribute the traffic to the web server 1 if we click multiple times also. So that's the end of this demo. Let me move on the next concept. So let us discuss about the load balancing algorithms. There are 4 types of load balancing algorithms. The first type is round robin algorithm. So what does this means? The requests are forwarded to server in a circular order, one after the other. So what we did previously, this is a round robin method. So first request goes to the server 1, second request goes to the server 2. So that's the round robin method. So if there is only equal capacity server with similar performance, so that will take care. The second one is weighted round robin algorithm. So these servers will have higher weight, better hardware or capacity. So it will get more requests. For example, so let's take a server having different specification. So one EC2 instance has 2 virtual CPUs and the second EC2 instance has 4 virtual CPUs because the second server will have a more weightage. So the more traffic will go to the second server. Weighted round robin. So then the traffic will distribute in the ratio 1:3. So first one is round robin, second one is weighted round robin, and the third one is least outstanding request. So least connection. So the load balancer sends traffic to the server with the fewest active connection. So for example, uh, EC2 instance 1 has 5 open connection, EC2 instance 2 has 2 open connections because the user is having a active connection or a live connection. So if he leaves only, the connection will drops. Least outstanding request. EC2 has 2 open connection. So then the upcoming incoming traffic will goes to this second EC2 instance because it has a least open connections. The next algorithm is IP hash or source IP affinity. So in this, the hash of the client IP address decides which server to use so that the same client always it's the same server. So if the client IP is 1.2.3.4, so it will go to the EC2 instance here. So if he comes back after some time and it's the same address, so it will go to the same server only. So that's the concept behind IP hash. Client IP1 having 1.2.3.4 as an IP address. When he makes a request, it will go to the EC2 server 1. So after some times when he hit the same IP address, it will go to the same EC2 server 1 only. In between there are multiple requests. It will go to the different EC2 server. So let's go for the OSI model layer because the networking concept has to be very good. So let me explain you how the data is transmitted from layer 7 to the layer 1 and layer 1 to the layer 7. So let's start with the application layer. So it handles from as a layer 7. Let me name it first. Next layer is presentation layer. It handles at layer 6. The next layer is the session layer. It's a layer 5 of an OSI model. And the next layer is a transport layer. It is layer 4 in OSI model. The next layer is network layer. It is a layer 3 in OSI model. The next layer is a data link layer. It's a layer 2. And the next last layer is a physical layer. It's a layer 1. So let me explain how the application layer works. So when you browse any web address such as youtube.com, or if you type any browser address and click enter, so it first initiates a request. It first initiates a request. So these requests are forwarded to the presentation layer at layer 6. So in presentation layer, so these requests are formatted to HTTP protocol, and it is encoded for data security. So whatever the request are formatted according to HTTP protocol, and it is encoded. Then the HTTP request are forwarded to the session layer in layer 5. So what happens in layer 5 is that, so the browser will establish a session with the server hosting the website. Browser will establish the session with the server hosting the website. And they also set up the parameters for communication. So then the request is forwarded to transport layer. So in transport layer, the browser breaks the request into smaller segments and adds a header containing TCP information of source and the destination port number. So the browser breaks the request into smaller segment and adds TCP header of source port and destination port. So then the request is forwarded to network layer, the TCP headers. The TCP segments are further encapsulated into IP packets. So in this layer, the browser determines the DNS server. So it will fetch the domain IP address using the domain name. The IP packets are forwarded to the data link layer. So in the data link layer, these IP packets are converted into frames. Like each frames contains the MAC address of the source and the destination address. IP packets are converted into frames. Each frames contains MAC addresses of source and destination. The last layer is physical layer. Here the frames are converted into electrical signals. And transmitted over the Ethernet cable or Wi-Fi. So this is the conceptual model, how the data is transmitted from the application layer to the physical layer. So from one browser to the server, how the data is fetched and vice versa. Okay. So let's take a break for 15 minutes and come back at 8:15. So let's take a break for 15 minutes and come back at 8:15. Hello guys, do you have any questions regarding the load balancer? So what is load balancer? Like why do we use load balancer? So what are types of load balancers and how do we set up the load balancers? Do you have any questions? Please ask the questions. The chat is open. So any doubts regarding the load balancer? See, the load balancer means like whatever the incoming traffic, like there are a lot of users, they'll be accessing that website. So if that website, the server will be running on that website. So there will be a lot of incoming traffic to that server. So the server should not get load. So that's the reason. So we are distributing the traffic across a lot of servers. Okay, let's move on to the next topic. So next topic is auto scaling. Let me share my screen. So what is auto scaling? See, it automatically scales up or scales down the resources based on the demand, like the resources like EC2 instance, ECS means container services, DynamoDB for databases. So to meet the current market demand, so why we use autoscaling means this because to keep up the application running smoothly during the traffic spikes also. Also we use for cost optimization. So whenever there is the application is not running, the server is a waste. So what is the main goal of autoscaling? So to maintain availability. So by adding uh, instances during the high demand and removing them when not in use. So the next thing is to optimize the cost by removing only the necessary resources. Also to achieve the fault tolerance by automatically replacing the unhealthy instances. So what are the components of auto scaling? Firstly, we have auto scaling group. So this is art of EC2 instance. So what does this does this? So it manages a collection of EC2 instances as a group. So in this we have launch template. Or launch configuration. So this defines how to launch an EC2 instance. So by selecting which AMI or instance type or key pair or security group. So this defines like how to launch an EC2 instances. By selecting the key pair AMI image instance type. So we can also set up minimum size. So we can set up minimum running servers, that is EC2. So we can set the limit in maximum size, how many servers it can reach. So we can set up the upper limit. So next is desired capacity. So it's a target number of the instance. It's an auto-scaling group. It will try to maintain this reserved capacity. So we can define the minimum size, the maximum size, and the desired capacity in the launch template or launch configuration. The next component is scaling policy. So this will define when and how to scale. So when and how to scale the resources. So firstly, we have dynamic scaling. So what does dynamic scaling does? So it responds to the real time like metrics like CPU utilization, network traffic utilization. So based on the custom CloudWatch metrics, so suppose like if the CPU utilization reaches 60%, it will increase the instances, or if the CPU utilization comes below 30%, it will remove the instances. So it's a dynamic scaling. Response to real-time metrics like CPU network utilization. And the next thing is predictive scaling. So it uses machine learning concepts to forecast future traffic based on historical trends. So it will automatically adjust capacity ahead of demanded spikes. So automatically adjusts capacity ahead of demands. So if you know if there will be a large number of users in the coming days, so we can predict using a machine learning algorithm. Then we can use this predictive scaling. And the next scaling method is scheduled scaling. So it's based on the time. So for a particular day, so let's take an example. So at every day, like 9 a.m., so it should increase the instances count to 5. And by 9 p.m., it should decrease the instance count by 3. For example, every day at 9 a.m., it should increase the instance count to 5, and by 9 p.m., it should decrease the instance count to 3. So this is all about predictive scaling. Sorry, scheduled scaling. Let's move on. So next component is L check. Because AWS monitors the health of the EC2 instance. If like if any instance fails an L check, it will automatically replaced. So L checks can be done by either from two states like EC2 state checks or EC2 load balancing health check. If any instance fails, fails a health check, it is automatically replaced by using EC2 instant check or load balancing health check. So what are the types of auto scaling? So let me explain you the types of auto scaling. The first one is horizontal auto scaling. The second one is vertical auto scaling. So what happens in horizontal auto scaling means, so it will add or remove multiple instances to handle load. So there will be no downtime. So similar number of instances is replicated in horizontal auto scaling. So it is mainly used in web servers, containers or microservices. So what happens in vertical auto scaling is, so it increases or decreases the resources like the CPU, RAM, network throughput of a single instance. So for example, so we are going to change the instance type from T2.micro to T2.medium for, like, we are increasing the capacity. So that means vertical auto scaling. So it requires a downtime. So when we're doing vertical auto scaling, we need to stop the instance and resize the instance. So whereas in the horizontal auto scaling, so there is no downtime because we are just replicating the instances, similar instances. So horizontal auto scaling, vertical auto scaling. Adding or removing the instances to handle load. In this, in vertical auto scaling, we are just increasing or decreasing the resource capacity. Like CPU, RAM, network throughput. So let me go through how autoscaling works. First, we are going to first we are going to define the launch template. like how do we define means choosing an AMI image for instance type security group and key pair. The next step is creating the auto scaling group. By specifying minimum, maximum, and desired instances. The third step is setting auto scaling policies. By selecting dynamic or scheduled or predictive scaling policy. The fourth step is networking with the CloudWatch. And the fifth step is target tracking policy. So let's start implementing in AWS Cloud. So go for the launch template and create a launch template. So naming as my demo launch template. Naming description as demo testing. And selecting auto scaling guidance. So selecting AMI image as Amazon Linux, so instance type as T2.micro. So North Virginia key pair I'm selecting. So selecting the security group. So auto assign public IP I'm enabling. So selecting delete on termination, yes. So it should be deleted on termination. So storage keeping as default and creating launch template. Next, create auto scaling group. So naming it as demo auto scaling group. So here we are choosing the previously created launch template, my demo launch template. Click next. So I have created in a default VPC. Selecting all the subnets. So next. So keeping everything as default. So keeping desired capacity 2 and maximum capacity 2 and minimum capacity 1. So keeping everything as default. Click next. Review this and create auto scaling group. you can see these two servers are creating automatically by using a launch template in auto scaling group. So it is now up and running. So when you go back to the auto scaling group, you can see it successfully created launch instances. So when we go back to the instance and delete one of the instance, so it will automatically create a new instance. So when you go back to the auto scaling group and check the activity, now the instance is terminated. A new instance is getting created. You can see the pending here. So we can confirm that it is automatically scaled. So that's the part of the demo. So do you have any questions? Please answer in the chat. So do you have any questions, please? So explain how auto scaling works. That's the question. So for example, imagine you're having a web application which experiences sudden surge in the traffic. So you manually cannot scale EC2 instance. Uh, so to handle such huge amount of spikes, so it will be very time consuming and it will be very inefficient. So the auto scaling group will automate this process like by defining the auto scaling policies based on the metrics like CPU utilization, like if these metrics hit the threshold, so the auto scaling group will automatically launches new instances or terminates the existing ones. So that's how auto scaling works. So does auto scaling mitigate the DOS risk, or is that done with a service like Cloudflare? Yes, Cloudflare can do. Even the AWS web application firewall is there. Also, we have AWS Shield, which will protect directly from DDoS attacks. So target tracking is not about the specific number of instance. It is about maintaining a specific metric value like CPU utilization. So for example, if average CPU utilization is greater than 60%, and if the minimum CPU utilization is less than 60%, like we will give you the metrics like add instance or remove instance. So it's a group average CPU value. So any more questions, guys? Yes, we're going to wind up the session now. So let's connect tomorrow. Thank you, guys.